In this tutorial, we are going to discover how to create graphic user interfaces in order to be able to input data into your Babylon.js apps. First and foremost, we need to install the GUI module, so in the command line I'm going to type this command and then of course import it into the project. Next, I'm going to create a canvas that will include all of the GUI elements that I'll be creating in the next sections. To do that, I'll simply create an instance of the advanced dynamic texture in the full screen mode. The string here is just an optional name for the instance. Now that we have our dynamic texture ready, let's start introducing elements to it. The first thing I'm going to do is add a button, so here I'm going to call create simple button. The first argument is a name, and the second one is the text to be displayed on the button. Next, we need to add it to the dynamic texture. As you can see, we got the button, but it has an invisible background and it's taken all over the canvas. To fix that, we need to set a specific width and height to the button, because by default most of the elements, aka controls, take the full width and height of the dynamic texture. We can change the color of the text, and the color names here are the same in CSS. To fix the invisibility of the background, we need to set a background color. We can create another type of buttons which basically include an image. To do that, we need to call create image button, and the third argument of the method is the URL of the image. To update the placement of the image, we need to use a side property like left, which basically sets the distance between the image and the left side of the button. Now, to set what should happen when a certain event occurs, like when the pointer enters the button or when it's up, we need to use one of these observables. And within the callback function, we can do whatever we want. So let's change the color of the mesh, for example. Another control we have is text block, which obviously adds text to the dynamic texture. We can change many of the text properties like the color of the text, the font size, and the font family. We can also add shadows. We have a few controls for text inputs, and one of them is input text. Again, as we didn't set a height to the input, it took 100% of the height. So I'm going to set the width and height, and 0.2 here means 2% of the canvas width. To set the default text to the input, we need to set a string to the text property. The text doesn't appear because the color of the background and the text are the same, so let's change that. And again, when the input is on focus, the color of the background goes back to black. To change that, we need to use the focused background property. Input has a set of observables for different events. So say for example we want to change the color of the torus whenever the input's text is changed. To do that, I'm going to use the onTextChanged observable, and I'm going to pass the text as a value to the blue channel of the torus color. Another control we have is the slider. Minimum and maximum here are obviously the min and max values we can set using the slider. And then again we need to pass a width and height to the slider if we don't want it to take all over the canvas. Value represents the initial value we want the slider to be in. Then we have a set of observables to use. In this case, I want to change the scaling of the torus every time the slider value gets changed. The last example of data input that I'm going to show you is the color picker, which we are going to use to change the color of the mesh. However, keep in mind that there are a lot more controls to discover. In this section, we are going to talk about helpers. Helpers are basically methods that we use to save some lines of code to create checkboxes and radio buttons. That said, let's actually create a checkbox which we are going to use to enable and disable the wireframe mode, for instance. And I'm going to do that the usual way, I mean without helpers. So as you can see, we had to type all of the code we've typed just to get the checkbox without a label. So to add a label, we'd need another set of lines to create a text block and put some work to place it exactly near the checkbox. Or we can use the helper, which is going to take care of that with just a couple lines. To do that, I'm going to call addHeader, which first argument is the checkbox, the second is the text, and the third is the space between the checkbox and the label. Next, I'm going to set a color to the text, then add it to the advanced texture. And there we have it. Now, to make the label appear before the checkbox, we are going to add an object as fourth argument. And here we can specify if we want the label and the checkbox to be displayed horizontally or vertically, and also if the checkbox must be on the left or the right side. We can also use another helper which decreases the code needed even more. So I'm going to comment out this block of code, and what I'm going to do instead is call addCheckbox with header. The first argument here is the label, and the second one is a callback function. Now, if you want to get access to the checkbox, you do that by using the children property, which is an array that contains both the checkbox and the label. Another helpful function we have is clone. This method makes it easier and with less code to create copies of the same control. So let's make a copy of the button. This line sets the button to the right side of the canvas. By the way, I'll get back to the positioning properties in a minute. And now that I've created the button, I need to add it to the advanced texture. Something you need to bear in mind is that the observables are not copied, so as you can see here, pushing the button doesn't do anything, hence we need to redo that for every copy we make. Now, time to learn how to position controls on the canvas. The first method is to use the vertical alignment and horizontal alignment properties. So here I can set center to center the button horizontally, or left or right. And of course we do the same thing to place the control vertically. Now if you want to set your control at a certain point, you have to use the left and top properties. It's basically the same way you position absolute elements in CSS. Speaking of CSS, with Babylon.js GUI we have the ability to create container elements in which we position elements the way we want and then position the container itself on the canvas. That said, to create one we need to make an instance of the container class and append it to the advanced texture. The container width and height take 100% of the width and height of the canvas. So let's reduce the width to half and place it to the left side of the canvas. By default, the container doesn't stop the pointer from interacting with the scene elements such as the camera. To make it do so, we need to set the isPointerBlocker property to true. Furthermore, we have a couple types of containers. One of them is rectangle. As its name suggests, it's a literal rectangle with a border. That said, we can change the border radius and thickness, and let's actually put the button inside of it. And as you can see here, the button positioning is now relative to the container, which is its direct parent, instead of the entire canvas. So if, for instance, I want to center it, I have to commit the following changes. The second type of container is the ellipse. We have also stack panels, which are kind of special type of containers, and what's special about these is that they auto-position and organize their children. So let's make 3 buttons and add them to the panel. And there we go, we got the buttons stacked vertically. If I use the container or add the buttons directly to the texture, they'll be placed on top of each other, unless I do some manual positioning, of course. And you can change the order of stacking to horizontal if you want to. Debugging with the browser inspector is an essential part of building interfaces with CSS, and the same thing can be done using the Babylon inspector. So since I have the module imported, I'm just going to uncomment this line. That done, as you see here, I got this GUI drop down, and from there we can do as many changes as we want. So I can change the opacity of the button's image, change the alignment of the text and the font family, etc. We have the ability to make controls stick to meshes. To do that, we just need to call the link with mesh method from a control and pass the mesh as argument. Furthermore, we can set an offset between the control and the mesh using the link offset X and link offset Y to set horizontal and vertical offsets respectively. Another cool thing we can do is make controls take the shape of meshes. So say I want to make the color picker take the shape of a plane, for example. I'll uncomment the color picker code and create the plane. Next, I'm going to create another advanced texture, but this one is going to be for the mesh I've just created. Now let's try to use a sphere instead of a plane and see how the picker is going to appear. And we can go even further by making the control always face the camera using the billboard mode property. So until this point we've seen how to create GUIs using code and how to debug with the inspector, but what if I tell you that Babylon.js offers you the ability to create your GUIs using a drag and drop solution? Well, such a solution does indeed exist, so open a new tab and go to gui.babylonjs.com, and there you have it, a clean interface that makes it way easier to build GUIs for your Babylon.js apps. Now let's make a very simple example, which is going to be a container that holds a slider to scale up and down the torus. So I'll start by making a rectangular container. Next, I'm going to create a text block that is going to serve as a label to the slider. And then of course I'm going to add the slider, stylize it, and most importantly add a name to it, which we'll need later on. Now we have two options. I either save it on the server as a snippet or save it as a JSON file on my local machine. That said, let's try the first option. So here I'm going to hit save to snippet, and with that done I got an ID to this particular snippet. Now to add it to my app, I'm going to comment out all of this code since we can't have two full screen UIs. And then down here I'm going to create a brand new advanced dynamic texture. To load the snippet into it, I'm going to call parseFromSnippetAsync and pass the ID, and since I used the keyword await here, I'll need to put it at the call of the function and put the async keyword at the definition stage. And just like that, we got our GUI. Now say we want to go the JSON way. I'll go back to the editor and instead of save to snippet, I'm going to hit save. That done, I'll move the file into the project folder, and inside the code I'm going to call parseFromURLAsync and set the URL of the JSON file. Finally, we got our slider, but as you can see it's not working because we didn't link it to the scaling property of the torus mesh. So to get access to the slider, we need to call getControlByName, and here we need to pass the name we've set earlier to the slider as argument. And now we are able to deal with the control the same way we did with the one we've created manually at the second section of this video. And this is it for this tutorial, so make sure to like, share and subscribe, and I will see you in the next one.